this podcast, we are going to go over the common naming system as well as the IUPAC naming system for ethers. All right, so ethers are a family of organic compounds that have two branches attached to a single oxygen atom. There's a couple different ways that we can show those, as you guys are seeing on your screen right now. We can say any chain length of carbon connected to an oxygen with another carbon chain of any length on the other side. So it's kind of sandwiched between two carbon chains. We can also show it, as we're seeing in this center one, we can show our lone pairs on oxygen. This is showing us that there are only two places for anything to bond to that oxygen molecule. Here we have two carbon chains replacing our R groups. And sometimes you will see this written in shorthand, and I think it's a little tough sometimes to see that this is an oxygen and not a carbon, but for your condensed structural formulas, you'll most likely see it like this most of the time, unless somebody's really trying to draw your attention to that oxygen by including those bond lines. So in order to make an ether, you're going to have two alcohol groups come together. Say, for example, you have, I don't know, two alcohol groups come together. We will remove a molecule of water from there, and what we are left with is our ether. Don't get hung up on this particular reaction, just kind of setting the stage for later. When we talk about reactions of alcohols, we'll actually go into the formation of ethers, but just know that it's formed from two alcohol molecules. So we really talk about simple ethers more than we get into more complex ethers, and because of that, we tend to stay more with the common naming for ethers, so we're going to practice that first this time. So when you see an ether, you're going to start by naming the groups attached to the oxygen atom, and then you add the word ether. Make sure in your name that your groups are being named alphabetically, so they have to go in alphabetical order. All right, so here we have an example. I like to draw boxes around my two R groups. So my first R group is a single carbon long, so I'm going to name this as an alkyl group, so that's methyl. My second R group is two carbons long, that is ethyl. So all I have to do now is just alphabetize these guys, name each group, and add the word ether. So this would be ethyl, methyl, ether. All right, sometimes you may see an ether where you have the same branches on each side. So instead of saying ethyl, ethyl, ether, which is really redundant, we can just say diethyl in this situation. So, oh my gosh, it just gave you the answer to the question that popped up. Let's pretend we didn't know the answer already. So here we have a carbon chain, and I'm reading those hydrogens are just falling behind those carbons. It's kind of hard to see it backwards. So we have an ethyl group on one side, and we have another ethyl group on the other side of our oxygen. So we would call this diethyl ether. All right, so common naming is reserved for simple ethers, and that's mostly what we're going to see in this class, but every now and then you're going to come across a more complex ether, and when you do, you're going to have to use the IUPAC system for naming those more complex ethers. So you're going to start where you always start. You're going to find the longest carbon chain, and you're going to make that your parent chain. So you're going to look on one side of your oxygen and then look at the other and figure out which side has a longer chain. You're then going to take the opposite side, and you're going to the opposite side of the oxygen, and that's going to become an alkyl group. So the other R group on there is your alkyl group, one is a parent chain. Instead of naming it, say, methyl with the YL ending like we do every other alkyl group, you're going to change that YL ending to OXY. So methyl becomes methoxy. Let's see this in practice. On our first example, the cyclopentane is going to be our parent chain. Okay, so this is cyclopentane. And I look to the other R group attached to my oxygen, and I do have a methyl group. So as you remember, we're going to take methyl, we're going to omit the YL, and that becomes methoxy. So this would be methoxycyclopentane. There's no numbering to do because you have only one option. One parent chain is coming off of one side of the oxygen, the alkyl group is coming off of the other. So now would be a fabulous time to pause me and attempt the other problem on here and then pick it back up when you've tried this. All right, for the next problem, I'm going to approach this the exact same way. And I am going to try to find the longest parent chain attached to one side of that oxygen. That is obviously going to be 4 carbons, and that is going to be butane. So I'm going to name that as my parent chain. This is butane. All right. The other R group on my oxygen is going to be a methoxy group. What is strange about this, and it's just adding kind of an extra layer to this, is this oxygen could be attached to the first carbon, could be attached to the second carbon. Well, that's the second carbon again. It could be attached either to the first or the second carbon. So if you can imagine this, we have an oxygen here. We could have a chain that looks something like that. So it doesn't have to necessarily attach to the end. So when you have multiple places that you can attach this oxygen group to, we are going to have to number. So it is okay in this situation to put your 1 ahead of everything else. So this would be considered 1-methoxybutane. We know that the methyl group is coming off of the oxygen, but the 1 is going to designate that the oxygen is attached to the first carbon or the carbon in position number 1.